All right. Good afternoon, everybody. It's 3:45. I'm going to say, in out of respect for everyone's time, we'll just get started. Um, I'm Lawrence Lee. I know I haven't been out and about as much as I'd like to be in the buildings, but I'm Lawrence Lee. I'm the math guy. I think the last time a lot of you saw me was back in August. The during teacher orientation. So it's good to see you all again, some of you, and good to see some of you for the first time. Um, oh yeah. So in the chat, Mike, I'd like to introduce Mike Carroll. I'm sure you've seen him around. He's probably out and about a lot more than I am, helping out with technology and everything. But in the chat, Mike dropped the attendance spreadsheet. And to get started, let me share my screen. So you should be able to see a not a Nearpod, a Pear Deck, right? So yeah, the funny thing is I stopped teaching. I left the classroom right before all of 2020 happened, and we were, everybody was just, forced to use things like Pear Deck and Nearpod and everything. So okay, so Mike's going to put a link in there as well.
Law, do you want me to share the screen, or what works best for you? Whatever works best for you.
No, that's fine. I mean,
Okay.
I've got it up. Why can't my mouse go there now? Okay, my mouse is there. I'll just start the class, and we'll see if people can access it. I believe you.
I don't have the link for your session, but if people, you know what we can do? If you go to, and I'll put this link in, if you go to joinpv.com, and then the code is what's in the top right, UNUWOY. If you type in that code, everyone should be able to jump on the Pear Deck.
All right. So is everybody able to join the Nearpod? Well, not the I keep on getting this mixed up. Deck. Because yeah, during that fun time, my wife, she's also a teacher. She used Nearpod a lot, so I kept on hearing Nearpod. That's why I get things confused. So, and like a typical administrator, I'm not up to date in what's really that current and what you guys are using every day, but I'm trying. So, all right, today's session is going to be on effective teaching practices. Just to take a look at some bigger ideas of how kids learn mathematics the best. I mean, we talked about this year. We talked about guided math, setting up an instructional framework for guided math to be able to meet and make that personal connection with students during your math block. We also talked about discourse. And the importance of math talk, getting students to talk a lot, and to help further their understanding of mathematics. So we're going to take kind of a step back and look at the bigger picture of how students learn mathematics. This is all adapted from a paper written back in 2005 from the National Research Council. It was basically called How Students Learn, and they addressed how students learn different subjects, mathematics being one of them. So I'm pulling all of this, and I'm saying that just so I don't get nailed for plagiarism, even though I could have cited a little bit better. But moving on. So our outcomes for today is to understand the importance of flexible thinking in our mathematics classrooms, both with, flexible thinking on the part of teachers, and also identifying the flexible thinking of students as well, and using their different ways of approaching and thinking about problems. because it's really, really good stuff, you know. I happened to be at McKinley a couple days ago, and I sat in on a small group, a pull-out group with you know, that Tamika Holland, you know, pulled out along with Kat Bremble, and just watching the kids work on problems differently. I saw some pretty cool things, you know, and thought, you know, wow, like, you know, we need to grab that kid and kind of like capitalize on that, and, you know, and tell that kid what you're doing is awesome. Keep going with that line of thought, even though it's probably different than what was taught or how things were taught, you know, or than the traditional method. The conceptual understanding of mathematics, you know, and just really understanding what conceptual understanding is, the difference between conceptual understanding and procedural understanding, and understanding the importance of math talk as a learning tool. So not just as a way to kind of fill time, but to really use students to teach themselves, and to help students develop their own deeper understandings of what they're learning. So let me pause here. Are we all right? Okay. So for everybody joining us, we are on a Pear Deck. And if you type in joinpd.com and type in the code in the upper right-hand corner that you see, follow along. I need to adjust what's on in my surroundings here. All right. So let's start off with a problem. You know, I'm not going to talk about how to do problems. I know it's been a long day. It's Wednesday of all days. We're not even done the year, or done the week. And I'm going to ask you to do work. But here we have a problem. A group of pirates divided some gold coins and some silver coins between them. Each officer received some gold and some silver coins. Each sailor received some gold and some silver coins, and each cabin boy received some gold and some silver coins. How many pirates are there in the group? So what I'd like you to do is, and I believe this is something where, nope, I'm going backwards. All right. To kind of enter in number one, what do you notice about the problem, and what are you wondering? So I believe you should be able to, at this point, type in responses of what do you wonder and what do you notice about the problem. Are you all able to type that into the actual Pear Deck slide?
You're not able to type it into the slide or draw on it.
Okay, I thought I set this up to draw in.
Well, I think slide 5 is set up for drawing. If you want to skip to slide 5, they can.
Okay, there we go. Oh, no. All right, that's right. I see the pear in the lower. That's a big giveaway. All right, so let's do this verbally or through the chat. What do you all right, where's my pointer? I'm out of my element here, as I am at home because my child got sick after I took her to the doctors, so I kept her home. She did want to go back to school, but at 2:00, and I didn't want to do that to her teacher, and just drop the kid off at 2:00. So, all right, so let's take a look at what's in the chat of what you notice and what you wonder. Good, there are no numbers. Not enough information. There aren't enough numbers. How many of each? Okay. Good. Okay, good. So these are good questions, and it's good. This is a technique of starting off problem solving. All right. Is everyone considered a pirate? Because what I've noticed over the years of teaching is, you give a word problem, and kids look at it, and they're waiting for you to give them the answer. They're waiting for you to give them the information. If we start off by taking out what kids expect, like the numbers, like how many of each there are, what there is, it forces people to be engaged and to really look and start thinking about, okay, what do I need? All right, and to think about the aspects of the problem. So, are the officers, sailors, and cabin boys considered part of the pirate group? Is everyone considered a pirate? There aren't any numbers. So, let's talk about what kind of numbers do we need? And yes, everyone is considered a pirate. So this is a pirate group, officers, sailors, and cabins. Okay. All right. So we're looking for numbers divisible by 3. What quantities do we need to start with in order to determine? Well, first of all, does anybody know what are we looking for?
How many pirates?
Yeah, how many pirates? And it's funny, like, at 20 years of teaching at the junior high school, it's like, the kids are still like, I'm like, hey, what are we looking for? And some of the kids are just like, I don't know. They're sitting there wondering, thinking about what happened at lunch, or about, what they're going to do that weekend. So, what we take for granted, as being obvious is not, so how many pirates are there in the group? So that's what we're looking for. We're looking for how many officers, how many sailors, how many cabins, what we need right there. Jasmine and Ryan, how many gold coins and how many silver coins? Good. So moving forward, we'll tell you. And Elena wrote out divisible by 3, which is pretty cool. So a group of pirates divided 200 gold coins and 600 silver coins between them. Each officer received 5 gold and 10 silver. Each sailor received 3 gold and 8 silver. And each cabin boy received 1 gold and 6 silver coins. How many pirates are there in the group? And then there's the answers. This was a multiple choice question. And I'll tell you in a bit where I got this from. But on the next slide, slide 5. So what we're going to do right now is I'm going to ask Mike to break us all up into small little breakout groups. Turn and talk. And this is I wrote turn and talk in case we were in person, but I was told that we're going to do this virtually. So in breakout groups, talk about what you would do to approach this problem, short of Googling it. Googling it is not allowed. And you can, on slide 5, on the next slide, you can draw or write anywhere what your solution would be. So I'm going to back up here. All right. So that's show responses. There we go. All right. Oh, I'm scrolling down. All right. Everybody see that? Cool. All right. So, all right, cool. So we got some equations going on. We've got some variables. X is gold, silver is Y. All right. It's a good attempt. All right. I got some smiling faces. Nice. I don't know. End of the day, that's all you're going to do. That's fine. We've got someone delete. Don't delete your response. Okay. 200. All right. Okay. All right. Well, this is a good start. So we had who put this response up with the X's and the Y's and all that stuff. All right, Madison. So why did you think to do that, Madison?
I just remember learning when having 2 variables that we can solve for one of them to find the other. It's just that when I started to do the work, I was like, oh my, this is a lot. So I that was just my start. I'm not sure if that's correct, but that's kind of where I was headed, that I'd find Y, and then I found Y and I got the equation for Y, and then I just plug in that equation for Y for the Y in the other equation. I don't know if that makes sense right now.
No, that makes perfect sense. And that's what we teach in algebra. And I know, you're all elementary and it's been a while since you had to do something like that. And, interestingly enough, that is how the person who shared this problem with me started. I got this problem from a former student. She reached out to me via email because last summer I ran into her brother, who I never taught, but recognized me from Abington at this science training in New Jersey. And I didn't teach him, but I taught two of his sisters and had his third sister in a PSSA group. So, I roundabout knew his family very well. And so his sister, he told his sister, hey, I met Mr. Lee. And she reached out to me with this problem and said, hey, can you help me solve this? And this was her attempt at a response, which was also my initial attempt, which is what, you did, Madison, and I'm sure a lot of others thought, okay, I vaguely remember doing this in algebra. So long story short, she started writing up different equations as well. There's actually 3 different types of pirates, X, Y, and Z. And that's what throws us off here. So she wrote up 3 different equations and just got really lost, And the same thing as well. I did the same thing too. When I looked at this, I got a piece of paper out, I got my pencil, and starting to write all these different equations, did all some fancy stuff, multiplying, dividing, and all that kind of stuff, isolating variables, and I came across the same roadblock. And I'm thinking, oh, what am I doing wrong? I've been teaching this stuff for 20 years. I should be a math expert. I'm ashamed of myself. And then, after I picked myself up off the ground after crying, I thought, hey, let me try something different. So here's another attempt at the solution. And if we could take a second and take a look at this, I said, all right, let me throw all this wealth of mathematical knowledge out the window and start off simple. Start off with 1 officer gets 5 gold and 10 silver, 1 sailor, 3 gold and 8 silver. The cabin boy gets 1 gold and 6 silver. And let's just stop there. That's 3 pirates, 9 gold and 24 silver. Now, the 200 total pieces of gold cannot be divided by 9. That stinks, But the 600 can be divided by 24 evenly. I sat there a bit. My kids are running around the house creating chaos. And then I decided we're so close. We're so close with the gold. Because I know that we can't divide 200 by 9, but we can divide 200 by 10. So what if I threw in 1 more cabin boy? So 2 cabin boys will get 2 golds and 12 silvers, and saw that it kind of worked out, just by what I call just messing around and finding out. I know there's another phrase out there similar to it, but we're saying, and I saw that we have the same ratio of 200 to 600 when I have 4 total pirates, 10 total gold and 30 total silver. And what I did was it was like a little eureka moment. I said, oh, I didn't use algebra really at all. No equations, no variables. And kind of happened to stumble upon the solution just by trying things out. And so I saw we had the same ratio of 1 to 3, which is what you get with 200 gold and 600 silver. So scale everything all up and you get 80 pirates. So the reason why I introduced that is because of, the fact that there was the canned way of solving it didn't work. The rules that we taught you in math didn't work. You have to use X, you have to use Y, and that's why. And it's nice that a former student reached out to me. It makes you feel good. But I also like this problem because it involved kind of throwing away what you think and starting from a different point. Getting stuck, walking backwards and saying, let me try it this way. So that's what we're looking at here, and that illustrates the whole concept of how students learn math. 3 key concepts. One of them is called engaging resilient preconceptions. The next one is organizing knowledge around core concepts, and then there's supporting metacognition. So resilient preconceptions. Kids come to your class with preconceptions, and there's two types of preconceptions we're going to take a look at. If we don't try to access those preconceptions, their ability to understand what you're doing in math is, going to fall. It's not going to be as solid. So let's start off with the first type of preconception. Some common myths about mathematics. Mathematics is about learning to compute, and you should be able to answer true or false. So that's one preconception we want to talk about. What do you think? True or false? Math is about learning to compute. There's a teacher dashboard. All right, good. So we're getting 8 falses. And that's, mathematics is so much more than adding, subtracting, multiplying, dividing. And you'll see that as you go through the years, especially at the younger grades. Those of you who teach kindergarten, first and second, you'll get a parent in first grade that'll say, you know what, my kid can multiply now. I think they're gifted. Just because they know how to do the process of multiplication, do they understand why, when we multiply, and what's it used for? So it's more than computation. Next preconception, mathematics is about following rules to guarantee correct answers. We can see that, that's false with how we, with that problem, the pirate problem that we just started off with. We're trying to follow the rules of writing equations, and, I failed, miserably over the summer when I tried working on that. So that's clearly false. And 3, some have the ability to do math and some don't. So you can go ahead and true, false this one. All right, we get some people say true. And some of you may feel that. Some of you may feel, I never got math, and no matter what I did, I can never learn it. Not the way that, the kid next to me did. Math, like everything else, that's false. Some people have the ability to do, some don't. I myself, and I used to tell this story when I taught. I used to tell kids I was horrible at math. I spent all of 9th grade in the back of class reading Stephen King books, about dogs killing people and stuff like that, instead of paying attention to math. And I had a hard time up until about 10th grade. I had a hard time with math, and even in 10th grade, I did it, but I didn't like it. I did it to get coach off my back, so I wouldn't get in trouble with coach, with my track coach. And then at some point, just something clicked, and I was able to understand math. Geometry, that's what it was. It was stepping away from the variables and the rules and looking at geometry and looking at a different type of mathematics. And after that, things clicked. The reason why I tell that story is because, I was a person who couldn't do math for a majority of my K-12 experience, but, with work, with being able to access different types of math and having different teachers who tried to show me different ways, I grew to become a math person, and that's all I do. That's all I want to do in my life, which is kind of weird. But, it's that growth mindset that we're not set doing one particular thing or having one particular skill set. I often say that I don't know anything about words, that I can't do. And which is, I say that kind of facetiously, but when I started my doctoral program, I went from struggling to write 3 pages to being able to crank out 20 within the same amount of time, just because the more you do something, the quicker you can do it. And now now that I'm not doing that kind of stuff anymore, I'm back to struggling typing out 3 pages. But again, if I had to and get back into that, I could probably get to where I can rip off 20 type pages in no problem. So, all right. Another type of preconceptions is drawing on knowledges and experiences that students bring. There's an idea out there called funds of knowledge. The kids, by the time, even in kindergarten, by the time they have reached you, they have a wealth of experiences and that they can draw upon that you can use to relate mathematical concepts to. They've been to the store with their parents. They run around the field. They're climbing up on these playground equipments and stuff like that. So there are ways of pulling in their experiences to make mathematics meaningful. So that's what we're talking about. That's what we're talking about here when we're talking about engaging resilient preconceptions. Number one, to ignore and to kind of counteract those that we just talked about, those myths, and to really get into engaging what they already know about math. They just don't know as math. They provide opportunities to experience discrepant events that allow them to come to terms with what they don't understand. And that was the pirate problem. I myself hit a roadblock and said, oh, maybe my method to start this problem isn't good enough. So let me rethink this. All right. And then to provide them with narrative accounts of the discovery of knowledge or development. In mathematics, not so much. I mean, there are stories with how certain concepts were developed, stories about theories. So not so much part 3, but, to focus really on that first idea of drawing on their knowledge and experiences. So, all right. Allowing them to use their own problem-solving strategies and not to lock into what the book says to do. And that's in everyday math, they teach different ways of multiplying. Those of you teaching 3rd and 4th grade, that's why. We're doing lattice, we're doing US traditional, we're doing partial products. We're allowing for different ways of solving problems and not locking kids into rules. Encouraging math talk, which we'll get into, and designing instruction activities that can bridge between what they understand and what their conceptions are, to take that past experience and connect it to the mathematics. All right. We are running out of time, so I'm going to skip this part. These are supposed to be skipped, so I'm going to go ahead and skip them. I thought they were going to be skipped, but all right. Knowledge around core concepts. So when you're teaching a lesson, it's important for you to understand what the core concepts of that lesson are. Not necessarily to teach them. It's easy to look at a lesson and say, oh, I know the process, but we need to make sure that they have a conceptual understanding of the mathematics that they're supposed to learn from the activity. All right. So there's different parts of mathematical proficiency. One is conceptual understanding why. One clear example that I just dealt with this past week is dividing by a fraction. My daughter was working on dividing by fraction problems, and my wife is like, oh, just flip the second fraction over and multiply. Whereas I'm trying to draw things out and say, this is why you multiply by 12 when you're dividing by 1/12. I'm drawing all sorts of pictures so she can visualize what dividing by 1/12 really means. It means dividing things into twelfths, into little bits called twelfths. So what I was trying to get at is her understanding of why that is. What my wife was just telling her just to get the homework done was procedural fluency. When you see when you're dividing by a fraction, always take the second one and flip it over and multiply. There's also strategic competence, ability to figure out how to solve it. Back to the pirate problem, to understand what do we do? What are different strategies? Because one method failed, another method could work. And that's what we want to teach our kids, to try different ways: adaptive reasoning and productive disposition. So what were the core concepts of that problem that we really need? What was, yeah. It wasn't writing equations and solving systems of equations, and it wasn't an algebra problem at all. What were the core concepts of the pirate problem? And you can go ahead and toss that into the chat. I'm going to go back to the solution. It's just going to let me go back to the solution. So the solution. So what is the main concept? Anybody just want to throw it out? Like, what are we really getting at? Yeah, understanding ratios. Okay. So that's what we're looking at, to identify that, oh yeah, 10 golds and 30 silvers is the same thing as 200 golds and 600 silvers. And understanding the ratios of scaling those ratios up, those equivalent ratios. So that's what we're really getting at. That's the core concept, that we want kids to walk away with from this problem, and understanding that, hey, the ratio, the ratio of 200 gold pieces to 9 people does not, 200 gold pieces for everybody to 9 gold pieces for these 3 people doesn't work. It's not equivalent. It's not a good ratio. It's not an equivalent ratio. So that's what we're looking at. So understanding that that's the focus of what we're getting at, that'll help us when we're guiding students through a discussion of this problem. So when, if like I did, if you give the problem to the kids and say, all right, pair up and start working on it and start walking around to listen to these kids speaking, if you know what they're supposed to be thinking and how, like what the core concept is, you can guide them gently to that, to that solution, or to that method, to that line of thinking. And that's a whole idea behind discourse. And while I click on these buttons, Camille, your question was strategic fluency. Are you asking what that, for more elaboration on what that is?
No, I was taking a stab at the answer to your question. What was the problem?
Okay, the core, yeah. So yeah, when we're talking about the core concepts, we're talking about the core concepts of the lesson we're talking about. So yeah, and that one wasn't so much algebra. That one was more of like, proportional reasoning, ratios. So
gotcha. Math is, obviously isn't my strong suit.
But like I said, it can be. I was that bum in the back of the classroom, barely getting by. Somehow I passed algebra. I have no idea how, but yeah. And I gotta say, I ran into my algebra teacher years later at a conference, and he looked at me like, "You doing what?" So he couldn't believe that I became a math teacher. And so the last part is supporting metacognition, and that's that math talk. That's what we talked about back in November, discourse. And that's what we want to get our kids doing. And that's the math program that's coming up down the road in the fall is heavily based on getting students to talk, and to discuss and to throw around ideas, no matter how right or wrong they are. And for you as teachers, you're not necessarily going to be teaching. You will, but you'll also be guiding that discourse. To be able to effectively guide that discourse, you need to know what the core concept is, and also to kind of give up that control. Let kids talk about stuff. In between talking about math, they're going to talk about what happened in I don't know what TV shows my kids watch now. It's all wacky. I watch it with them. I just don't know what they're called. So. But that's metacognition. Skipping over this because we have 3 minutes left. But discussing in the 5 minutes I gave you, and I know I didn't give you a lot of time, but discussing amongst your groups help in any way in terms of you getting an understanding of the problem? Or at least, you know, kind of figure out where to start. Okay. And you know, that helps for you to say, you know what does this mean? And to ask each other. You might not want to ask me. And you know, people don't want to ask the teacher because they're too intimidated, but to ask your other peers, there's low risk there. There's low risk. You know, I will freely say to anybody that I don't know anything. But that's me. That's because I'm almost 50 and I don't care what people think of me. But young kids are self-conscious. They want to be able to feel safe in expressing what they don't know. So, you know, the part of that, creating that safe environment is, you know, that allowing that math talk creates that safe environment for them to verbalize not only what they know, but what they don't know, and to help each other out. And that's key for them to make the mathematics meaningful to themselves. So those are 3 key ideas that I'd like to revisit for March 22nd. Those are 3 key ideas that we're going to touch upon as we prepare for this new program coming up. There's a lot of PD planned for everybody, focusing on math. That's really going to expand upon all of this. So I gave you like a quick 45-minute overview of these 3 concepts. You're going to see these 3 concepts over and over again as we go along. Real quick, I got 1 minute left. So next time, we're not going to meet. I am going to send out an email to you all as to what's expected. It'll be what's called async work. But to take a look at a lesson that you taught, that you're teaching, or that you will teach, and take a look and try to identify those 3 concepts in the lesson. I'm just going to go ahead and say, if you want to collaborate, like if a bunch of you teach 1st grade and want to get together and do the same thing together and submit one thing together as a group, to me, that makes sense. That encourages the math talk, the discourse. If someone, you know, if there's only one 5th grade teacher out there and you want to join some 4th and 3rd grade people, that's perfectly fine. And just kind of join forces, submit one Google form. That's perfectly fine, because the next thing I have here, I'm going to send out a Google form that looks like this, and it'll just ask you, you know, to fill things out, to examine everyday math lesson. I'm going to add a section where you can just fill in who you were working with. You know, 1 submission for like 3 or 4 people. I'm fine with that. That's called collaboration, and that's quite all right. It's not called cheating. So, and I'll give out more detailed and formal information for next time. So it's 4:30. I thank you for your attention and your time. And believe it or not, I swear, like, tomorrow's going to be April 8th, and in about 2 weeks, it'll be June 8th. So before you know it, this year's going to end, and you're going to wonder what the heck just happened. So, but it'll be good, and you'll enjoy a well-deserved summer. So I'll see you guys around, and everybody take care. Thank you for your attention and your time.